And I just did it again. Okay, I think Zoom might have malfunctioned. I thought I was recording when I wasn't. And I won't necessarily blame it on Zoom. I'll go over this pretty quickly. And in the meantime, I'll be working on this equation here. So first, to solve this equation, we multiply both sides, but we use a distributive law on both sides. So we multiply 4 by 2x and by -5, I got 8x minus 20. 7 times 3x plus 2 is 21x plus 14. I get this equation. I've got a minus 20 on the left-hand side. I add 20 to both sides. I write out the equation as I urge everybody to do at this point. And when I do the addition, I get 8x equals 21x plus 34. Then, and this is a step where some people got stuck. What are we going to do? We got x's on both sides. Well, subtract off the x's on this side, and they'll appear on this side. Okay? And when I wrote this out, I didn't have a minus sign in front of this 21x, although I treated it as if I did. So we're going to get 8x minus 21x when we subtract the left-hand side, add the left-hand sides, add the right-hand sides, we get 21x plus 34 and a minus 21x. 8x minus 21x is negative 13x. This side simplifies to 34 because the 21x's. Subtract off leaving us 34. And then we have an equation where we can simply divide by negative 13, both sides. We get x equals negative 13, negative 34 over 13. Okay. Now I'm going to stop. I'm going to go over this one. I did this one because people did real well with this one, okay? Even though we hadn't talked about solving formulas. I gave you this, ax plus b equals c, solve it for x, subtract b from both sides, you're in the habit of doing that, and write out what you get. And then simplify ax plus b minus I want to see how everybody's doing with the okay, the next thing we did was solve this equation. And people did pretty well identifying a common denominator here, but then didn't always use it correctly. Some people tried to put everything over the common denominator, which can work if it's done correctly. In many cases it was. But the point is to end up with an equation that doesn't have any denominators. If we multiply both sides by 15, well, we multiply this side by 15, there it is. Multiply this side by 15, and there it is. And then we just do what comes natural, okay? Now, some people aren't sure that this 3 being in the denominator, well, aren't sure that the 3 is in the denominator and the 15 is in the numerator when I write this out, okay? So 3 is the denominator and 15 is a numerator, but just to emphasize that, we can always write 15 as 15 over 1. Then we can clearly see that 15 is a numerator. Now, the 3 will divide the 15. The 3 is a factor of the denominator. The 15 is a factor of the numerator. And what that means is a factor is something that you multiply by something else to get the denominator. 3 is multiplied by 1 if you simplify this, okay? And the 15 is multiplied by the x. So the 3 is a factor of the denominator. 15 is a factor of the numerator. You can divide a factor of the denominator into a factor of the numerator. Or you can think this fraction would still come out the same if I switched the 3 and the 1. And then I directly have 15 divided by 3. So for all those reasons, you can divide the 3 into the 15. And similarly, you can divide the 5 into the 15 here and get 3. You can divide 3 into 15 and get 5. Still have the 2 here. Then your equation becomes 5x plus 3 equals 10, and that's almost trivial to solve. You subtract 3, or when you subtract the equation, -3 equals -3 from both sides. Now, I kind of shortcut it here. If you do what I suggest you do 5x plus 3 minus 3 equals 7 minus 3, add the left-hand sides and add the right-hand sides. But you can see what's going to happen. And if you've done that a bunch of times and you're sure you're always going to remember to do that, maybe you don't have to. So anyhow, we get 5x equals 7, divide both sides by 5, and we get x equals 7/5. Now we check the solution, okay? X equals 7/5. We check, we get 7/5, that's x. X is 7/5, so x over 3 is 7/5 over 3. It's a complex fraction, but that's not too hard to deal with if we understand what it means. And then we have the 1/5 and the 2/3 just as they are. So I write this as 7/5 divided by 3, because that's what it is. 7/5 over 3 means 7/5 divided by 3. When you divide by a number, you multiply by the reciprocal. So it's 7/5 times 1/3 added to 1/5 equals 2/3. Okay. So we get 7 over 15 plus 1/5 equals 2/3. Now to add those up, we can do a common denominator of 15, and it's going to turn out like this, and we're going to get 10 over 15 equals 10 over 15. Alternatively, we could have multiplied both sides by 15, which would have wiped out the denominators and given us an equation that says 10 equals 10. Okay, but people are making progress on this, but you want to write out every step so that you get in the habit. So when you have to do it with a formula, you're going to know what to do. And we're going to do it with a formula. Now, I asked everybody to work this problem. People are making pretty good progress. They know to multiply through by the distributive law. Now, one thing I didn't say, oh man, I have to whittle this whole piece of chalk down to get it right. Solve for B. Okay, so let's solve for B. Now, you don't even focus on B at first. We've got a distributive law here, so we get AB plus AC equals D. And I think everybody got that. Okay. Now, some people weren't sure what to do from here, especially since I didn't say what to solve for. So what are we solving for? We're solving for B. So I'll just kind of underline B here. That's what we're trying to get. Now, do we have any terms on this side? Anything that's added or subtracted that doesn't have a B in it? Well, yeah, we got the AC. So we subtract AC from both sides, or we add the equation negative AC equals negative AC. Adding the left-hand sides, we get AB plus AC minus AC equals D minus AC. Then AC minus AC is 0. And we get AB equals D minus AC. Then we got to get B. We're still looking for B. I'll keep that underlined. So we're going to divide by A. Both sides. And the A's divide out. We end up with B equals D minus AC over A. Fair enough? Okay. Let's try a couple more. Make them just a little more complicated step by step. See how we do. That's an S there. It looks a whole lot like a 5. Let me make it a little more serpentine. Still kind of looks like a 5, but it's an S. Kind of grotesque S, but it's an S. Let's see what you do with this. Write out every step. Better with this thing, but there we go. Okay. It was kind of misbehaving, but I think it's picking everything up. And let me just do a quick sound test to make sure that we're not where we were before. Okay, here's our equation. Now, everybody, I think, correctly did apply the distributive law here. This is very good. We have ZQ plus RS equals QR plus S. Now, at this stage, people started doing a variety of things. And as I expected, needed to give the hint, okay, get all your S's on one side. Now, after you do that, I'm probably going to have to show you what you do next, but I wanted you to play around with it. In most cases, people got equivalent expressions at every step, but people were doing things like subtracting R from RS and thinking you ended up with S. Well, I don't want that. Okay. Anyhow, you do that. Okay, most people then ended up with their S's on the right side, so I'll do this. You would subtract RS. In other words, you would subtract the equation RS, negative RS. You'd add the equation negative RS equals negative RS to this equation, and you get ZQ plus RS minus RS equals QR minus RS plus S. Now, on the left, you got ZQ. On the right, you got QR minus RS plus S. Uh-oh. Now let me write out what you really get, because I didn't multiply the RS by Z. So it should be ZQ plus ZRS. So now we subtract ZRS from both sides by adding the equation negative ZRS equals negative ZRS. And this is then going to give us ZQ plus ZRS minus ZRS equals QR plus S minus ZRS. Q didn't come out very well, but I'm afraid to do much more to fix it. Okay. Now, ZRS minus ZRS is 0. So we have ZQ equals QR plus S minus ZRS. Okay, now all our S's are on this side. Next thing we want to do is make sure there's nothing that doesn't have an S in it on this side. And that's going to be subtract QR from both sides. Or subtract the equation negative QR, or add the equation negative QR equals negative QR, which gives us ZQ minus QR equals S minus ZRS. So if you got the thing down to an expression where one side was S minus ZRS, You're right on the verge of a solution. But remember, well, I'm not going to say it. Just because there's a Q here and a Q here doesn't mean that these Q's can be subtracted. Okay? This whole thing is subtracted from this whole thing. And if you think that the Q's go away, they don't. You're not dividing. If you divided this by QR, yeah, you would, but you wouldn't want to divide both sides by QR because that would kind of mess everything up. Okay. Now, I'm going to rewrite this because the thing we're trying to solve for is S. And I'm going to write something that's equivalent to this, and you can verify that it's equivalent. If you multiply this out, you get this, don't you? S times 1 gives you S, and S times negative ZR gives you negative ZRS, doesn't it? Okay. So write this step down. Don't write it down as part of your solution unless you happen to have this equation here. It's write what I have here and see if you can, by one operation, find the solution to the equation. Okay, now, everybody's having some problems. So we've reduced this equation to this form. Let me write it up here a little bigger. Try to write it out correctly. And then we get Z cubed minus QR, I think. Okay. What I would do is I would take S times 1 minus ZR and ZQ minus QR and divide both sides by 1 minus ZR. S is multiplied by this. If I divide both sides by this, I'm going to get S. That makes sense? So this is going to give us S equals CQ minus QR over 1 minus ZR. Okay? So if you end up with an S on both sides, it's kind of gives you a strategy. Now, thinking back on it, I kind of maybe would have taken this equation and solved it for Z. See what you get if you solve for Z. Okay, very good. Now, all you have to do here, a lot of people got this. RS, then Q plus RS is going to divide Q plus Rs. 1, which is Z. really hard to write a Q down that low. That's a Q there, believe it or not. And yeah, I think the camera picked it all up. Okay, understand that strategy? Now you should then be able to solve the equation. We have just a couple of minutes to see if you can solve it for let's see, what did we solve it for? We solved it for S. We solved it for Z. See if you can solve it for Q. I've only got a couple of minutes left. So get right to it. Oh, you go on. I'm gonna. Okay. I did this thinking the camera was on. I don't know what I was doing. The camera wasn't. It was. Okay. Same equation we're going to solve for Q. Here it is. We multiply through by the Q and we get this. And now we want to get all the Q's on one side. We had to multiply through by, let's say we'll multiply through by Z. Now we want to get all the S's on one side. I'm sorry, we're trying to solve for Q. We're trying to get all the Q's on one side. Okay. So we subtract, we have a Q here and we have a Q here. We do minus QR equals minus QR. This QR goes away and a QR appears over here. We get this equation. And now we have all the Q's on this side, but we don't want that ZRS on this side. We want that ZRS on the other side. So we add negative ZRS equals negative ZRS to get this equation. And now we can write 2Q minus QR, which is what we're left with in the left-hand side, as Q times a quantity Z minus R. And that's equal to what you have on the right-hand side. And now we can divide both sides by Z minus R. And there's our solution. Okay. So if we just see this one step, once all the Q's are on the side, we have them in common with every term, we can factor it out. We can do a reverse distributive law. We can verify that if we multiply this out, we do get this. So this must be the same as this. We're kind of doing the distributive law backwards. Okay, this is a little bit tricky, but I think y'all are in good shape to solve these formulas, especially with what open math is going to show you and so forth. I think we can do pretty well.